When you're working with real-time data, like a live financial feed, it feels like this constant battle, right? The market moves at lightning speed, data is just flying at you, and your app absolutely cannot miss a single update. So how do you build a Python application that can actually keep up with that? Well, the answer is all about asynchronous programming. And that brings us to this classic problem, the one everyone calls drinking from a fire hose. You've got all this valuable data gushing out, but it's coming so fast that your system just gets overwhelmed. It chokes, and you end up dropping most of that precious data right on the floor. See, the real challenge isn't just getting the data, it's building a system that can tame it. So, where do we even begin? Well, it all starts with how we get the data in the first place. We need to ditch the old clunky methods and switch to a modern approach that's actually built for speed. Let's compare the old way, polling, with the new way, pushing. Okay, look at this. The difference is just, it's night and day. With traditional REST polling, your app is like a kid in the back of a car constantly asking, is there anything new yet? How about now? Each one of those questions is a full, heavyweight HTTP request. And you're guaranteed to have these little gaps between each ask where you're completely blind to what's happening. But with WebSockets, you open one single connection, and the server just pushes the updates to you the second they happen. It's a continuous, uninterrupted stream. So, what exactly is a WebSocket? Just think of it like a dedicated open-lane highway between you and the server. Data can flow in both directions, instantly, without all the overhead of setting up a new connection every time. For low-latency, real-time data, this is the first piece of the puzzle you absolutely need. Okay, great. So we've solved the delivery problem. We've got our WebSocket, the data is just streaming in, it's beautiful. But we've just created a new problem, haven't we? A much more subtle one. What happens when that data firehose is flowing faster than your code can actually handle it? And the solution, it's actually this really elegant, really powerful idea called the producer/consumer pattern. The big idea is to stop trying to make one piece of your code do everything at once. Instead, you decouple the work. You create two specialists, one that does nothing but receive data, and another that does nothing but process it. Let's break that down. First, you've got the receiver, which you can also call the producer. This thing has one job and one job only. Listen to that WebSocket, and the instant a message comes in, grab it and stick it in a queue. It doesn't analyze it, it doesn't do math, it doesn't think, it just catches. And then you have its partner, the processor, or the consumer. Its job is just as specialized. It walks over to that queue, grabs the next message in line, and then it does all the heavy lifting. This is where you calculate the spread, write to your database, or do whatever complex logic your app needs. The key thing is it does this at its own pace, totally separate from the receiver. So what connects these two? What's the magic in the middle? Well, it's the asyncio.queue. Think of it like a conveyor belt or a buffer zone. This is the crucial link that lets our super fast receiver and our potentially slower processor work together in perfect harmony without ever dropping a single piece of data. So let's put it all together. Here's how the data flows through the whole system. Messages come streaming in from the WebSocket. They're immediately caught by our receiver, which in asyncio is just a special kind of function called a coroutine. It does its one job. It puts the message onto the asyncio queue. Then, a completely separate processor coroutine comes along, picks it up from the queue, and does its thing. This clean separation of duties is what makes the whole system so incredibly resilient. All right, that's the theory. That's the high-level architecture. It sounds great on a slide, but what does this actually look like in Python code? Let's take a look at how you'd actually build this using Python's asyncio library. When you translate this to Python, it maps really cleanly to a few key components. You'll have a receiver function and a processor function, both written as async coroutines. And then, to get them both running at the same time, you use something called an asyncio.taskGroup. You can think of the task group as a manager that kicks off both of your specialist workers and makes sure they run concurrently. And this right here is the beauty of the whole system. The processor can get slammed, it can fall behind, but the receiver doesn't care. It just keeps on catching data and stacking it up neatly in the queue. The system stays responsive, and more importantly, you don't lose anything. But hang on a second. What happens if the processor gets really far behind? Yeah, exactly. If that queue can just grow forever and the processor is slow, that queue is just going to keep filling up and filling up and filling up until, bam, your app runs out of memory and crashes. That's not a very robust system, is it? So how do we stop that from happening? So in the example code for this, you'll see this little number tucked away, 256. What's that about? It might look kind of random, but this number is actually one of the most important parts of the whole design. This little number is our safety valve. It's a concept called back pressure. By giving our queue a maximum size, we're basically telling it, hey, never hold more than 256 items at once. If it does fill up, the queue will actually tell the super fast receiver to just, take a little pause. This gives the processor a chance to catch up and prevents our memory from exploding. It makes the system self-regulating. Okay, so what we've just built is the core of a really robust system. But to take this from a cool little prototype to something you'd actually trust in production, there are a few more layers we need to add. I mean, think about it. In the real world, connections drop, right? So you need automatic reconnection logic, probably with some kind of backoff. You need to handle heartbeat messages, pings and pongs, to keep the connection from timing out. You'd obviously want to save the data to a database or a file, not just bring it to the screen. And chances are you'll want to subscribe to multiple data streams, not just one. So really, it all boils down to this simple formula. You take WebSockets for that super efficient data delivery. You add async Python with the producer/consumer pattern for robust processing, and what you get is a clean, decoupled, and incredibly scalable architecture for pretty much any real-time data pipeline you can dream up. And that's really the big idea here. Because we've decoupled these two jobs, the system becomes incredibly flexible. Right now, our processor calculates a spread, but what if you unplugged it and plugged in a new one that writes every message to a database? Or how about a processor that streams the data to a live web dashboard? Or one that feeds everything into a machine learning model for real-time predictions? Once you have this pattern in place, the possibilities are endless.